Tonight, we are going to do something most people never truly allow themselves to do. We are going to zoom out. Not just beyond cities, not just beyond continents, not even beyond Earth. We are going to zoom out until our planet nearly vanishes. Because here is something that almost no one feels in their bones. Earth is not just small. It is so small that, compared to the observable universe 93 billion light-years across and filled with roughly 2 trillion galaxies, our entire world becomes mathematically negligible. And once you see that clearly, you cannot unsee it. Most people live their entire lives without grasping this scale. Tonight you will. Welcome to Velorin, Sleepy Space Mysteries, where we gently drift through the cosmos not to overwhelm you, but to soften your perspective and quiet your mind. By the end of this journey, the problems of the day may feel smaller, your thoughts lighter, and your place in the universe both humbling and strangely comforting. If you enjoy these deep cosmic explorations, take a moment to subscribe, like this video, turn on the notification bell, and consider joining our membership to support more journeys like this. And before we continue, comment below where you're listening from. Let's see how far this tiny planet reaches tonight. Let's begin close to home. Not the poetic idea of home, but the physical one beneath your feet. The ground you walk on, the oceans you've seen on maps, the mountains rising quietly into the sky. From where you stand, Earth feels enormous. It stretches farther than you could ever travel in a lifetime. Its diameter is about 7,926 miles. If you could somehow stand at the equator and walk all the way around the planet, you would cover roughly 25,000 miles before returning to your starting point. Imagine walking at a steady pace of 3 miles per hour, 8 hours a day, every day, no breaks for weather, no oceans blocking your path. At that pace, circling Earth once would take you about 3 years. 3 years of steady walking just to make one loop around the planet. From a human perspective, that feels vast. Earth's surface area is about 197 million square miles. Oceans cover roughly 71% of that. Continents stretch for thousands of miles. Entire civilizations rise and fall within fractions of its total landscape. When you look out toward the horizon, it appears flat, endless, almost infinite. And for most of human history, this was everything. The entire universe, as far as anyone knew. The sky was a dome. The stars were lights. The ground beneath was the whole of existence. At our scale, Earth is not small. It is overwhelmingly large. But now, very gently, we begin to zoom out. Our nearest neighbor is the Moon. It has a diameter of about 2,159 miles. That makes it roughly 27% the width of Earth. Not tiny, not insignificant. If Earth were a basketball, the Moon would be about the size of a tennis ball. But size is only part of the story. Distance changes everything. The Moon orbits Earth at an average distance of 238,855 miles. That is nearly 250,000 miles away. If you stacked Earth side by side in a straight line, it would take about 30 Earths to bridge the gap between us and the Moon. 30 Earth diameters of empty space. When you see illustrations of Earth and the Moon together, they are often drawn close, almost touching. In reality, there is an immense stretch of nothing between them. That emptiness is important, because space is not crowded. It is not dense. It is not packed with objects. It is mostly void. Even in our closest cosmic relationship, the defining feature is distance. The astronauts who traveled to the moon took about 3 days to cross that gap. 3 days traveling through darkness, with Earth shrinking behind them and the moon slowly growing ahead. And still, on a cosmic scale, that journey barely left home. Now we widen the frame further. At the center of our solar system sits the Sun. Its diameter is about 864,000 miles. If you placed Earth across the Sun's face, you could fit 109 Earths side by side from one edge to the other. But diameter does not fully capture scale. Volume does. Inside the Sun, you could fit about 1.3 million Earths. Every ocean, every mountain, every city, every human who has ever lived. Multiply that by 1.3 million, and you begin to approach the Sun's size. The Sun contains 99.86% of all the mass in our solar system. Everything else, every planet, moon, asteroid, comet, together makes up just 0.14%. We orbit something that overwhelmingly dominates our neighborhood. The distance from Earth to the Sun is about 93 million miles. Light, traveling at 186,000 miles per second, takes 8 minutes and 20 seconds to reach us. When you feel sunlight on your skin, you are feeling energy that began its journey more than 8 minutes ago. If the Sun were to vanish, we would continue seeing it for those 8 minutes. That is how vast even this nearby distance truly is. And yet, in the scale of the galaxy, 93 million miles is almost nothing. Now we move outward again, past the inner planets into the realm of giants. Jupiter is the largest planet in our solar system. It measures about 86,881 miles across. That is roughly 11 times Earth's diameter. But in volume, the difference becomes staggering. You could fit 1,321 Earths inside Jupiter. Imagine stacking Earth after Earth after Earth, more than 1,000 times, and still having space left inside that swirling gas giant. And yet Jupiter, immense as it is still small compared to the Sun. Saturn follows, about 72,000 miles wide. Saturn could hold about 764 Earths within its volume. Uranus could contain about 63 Earths. Neptune about 57. Even the outer planets, which seem distant and cold and mysterious, dwarf our world in scale. And between Mars and Jupiter lies the asteroid belt. In movies, it appears crowded, dangerous, filled with tumbling rocks. But in reality, the asteroids are separated by enormous distances. If you traveled through it, you would likely see nothing at all. All the material in the asteroid belt combined adds up to less than 4% of the Moon's mass. Less than 4%. Again, the theme repeats. Mostly empty. Even in the densest regions of our solar system, space dominates. Objects are islands in a vast ocean of nothing. And we are not done zooming out. Far beyond Neptune, beyond Pluto, beyond the icy Kuiper belt, lies a distant spherical shell of objects known as the Oort cloud. This region may extend nearly 2 light-years from the Sun. 2 light-years. Remember, light takes 8 minutes to reach us from the Sun. To reach the outer edge of the Oort cloud, light would travel almost 2 full years. That is the rough boundary of our solar system's gravitational influence. Trillions upon trillions of miles. And somewhere within that enormous sphere, at a distance of 1 astronomical unit, 1 AU, sits Earth. One rocky planet orbiting an average G-type star. Even here, before we leave our own neighborhood, we are already small. If you're still listening, type 1 in the comments. Now let's continue drifting outward, slowly, calmly, without rushing the scale. We are still inside our own solar system, and yet the distances are already stretching beyond intuition. From Earth to Neptune, the outermost major planet, the distance averages about 2.8 billion miles. That is nearly 30 times farther from the Sun than Earth is. Light from the Sun takes a little over 4 hours to reach Neptune. 4 hours of continuous travel at the fastest speed anything can move. And even Neptune is not the edge. Beyond it lies the Kuiper Belt, a wide ring of icy bodies extending billions of miles farther. Pluto, once called the 9th planet, is only about 1,473 miles across. You could line up a little more than 5 Plutos across Earth's diameter. And yet, even Pluto is not alone. There are thousands of similar icy worlds out there, small, dim, widely separated. But here again the pattern repeats. The Kuiper Belt, though filled with objects, is mostly empty space. The distances between those icy bodies are vast compared to their sizes. If you were drifting through it, you would likely see nothing but darkness for long stretches of time. The solar system is not a crowded place. It is a collection of tiny objects separated by enormous voids. Let's pause and visualize something simple. Imagine shrinking the Sun down to the size of a basketball. At that scale, Earth would be a peppercorn about 26 feet away. Jupiter would be a large marble more than 100 feet away. Neptune would be nearly 900 feet away. You would need almost a full football field just to show the span of the major planets. And that still would not include the Oort cloud. To represent the outer boundary of the Oort cloud at this scale, you would need to travel thousands of miles from that basketball. That is how large our solar system truly is. And yet, compared to interstellar space, even that is just a tiny bubble. Now return gently to Earth itself. Our planet orbits the Sun at a distance defined as 1 astronomical unit, or $1. This distance feels vast to us, 93 million miles, but in the architecture of the solar system it is relatively close to the center. Mercury orbits at about 39 cents. Jupiter orbits at about $5.20. Neptune orbits at about $30. The inner rocky planets cluster tightly near the Sun, while the outer gas and ice giants spread farther and farther apart. The spacing grows as you move outward, like ripples widening on water. But even across those ripples, the dominant feature is emptiness. If you removed all the planets, moons, asteroids, and comets, the solar system would look almost exactly the same from a distance, because nearly all of it is nothing. The Sun, immense as it is, contains almost all the solar system's mass. The planets are like dust particles circling a glowing sphere. Jupiter, though able to swallow 1,321 Earths by volume, is still only about 1,000th the volume of the Sun. Saturn, holding 764 Earths, is even smaller relative to our star. Uranus and Neptune, at 63 and 57 Earth volumes respectively, shrink further still. Each time we compare, Earth becomes one small unit among larger ones. And even those larger ones become small compared to the Sun. Consider again the journey of light. 8 minutes and 20 seconds from Sun to Earth. 43 minutes to reach Jupiter. Over 4 hours to reach Neptune. Nearly 2 years to reach the distant outer shell of the Oort cloud. The solar system spans trillions of miles, and light itself needs years to cross it. And yet, on a galactic scale, this entire structure would fit comfortably inside a tiny speck. There is something calming about this realization. The vastness is not crowded or chaotic. It is quiet. Between every major object lies an overwhelming amount of dark, silent space. The asteroid belt contains less than 4% of the Moon's mass. The Kuiper belt is thinly scattered. The Oort cloud is so distant that we have never directly observed its objects. We infer its existence because comets occasionally fall inward from that far sphere. That is how empty it is. Its members are separated by distances so large that they are almost isolated from one another. So here we are, one rocky planet, 7,926 miles across, orbiting 93 million miles from an average G-type star. That star, 864,000 miles wide, dominating everything nearby. Around it circle a handful of planets, some capable of swallowing Earth hundreds or thousands of times. And beyond them stretches a shell of icy debris reaching almost 2 light-years outward, trillions upon trillions of miles. And still, we have not left our own backyard. If you step back far enough to see the entire solar system at once, Earth disappears almost immediately. It is not the largest rocky planet. It is not the largest planet. It is not even close to the most massive object here. It is one orbit among many, circling quietly at $1 Australian. Even here in our immediate neighborhood, we are already small. Now let's widen the lens even more, but keep the pace slow. We are still inside the invisible boundary of the Oort cloud, that distant spherical shell that may stretch nearly 2 light-years from the Sun. Imagine that for a moment. Light, moving at 186,000 miles per second, would take almost 2 full years to travel from the Sun to the farthest edge of this cloud. And yet, even that immense sphere is only the outermost whisper of our star's influence. Beyond it begins true interstellar space. If you were to float just outside the Oort cloud and look back, the entire solar system would appear as a tiny glow surrounding a single star. The orbits of the planets would be far too small to distinguish. Earth would not be visible at all. Even Jupiter, able to contain 1,321 Earths, would be swallowed by distance. Everything we have described so far would collapse into a faint point of light. And yet, within that point of light exists every mountain, every ocean, every story humanity has ever told. The Sun itself, 864,000 miles wide, is classified as a G-type main sequence star. It is not unusually large. It is not unusually small. It is average. Across the galaxy, there are hundreds of billions of stars, and many of them are similar. Some are smaller red dwarfs. Some are larger blue giants. But our Sun sits comfortably in the middle range. Ordinary, stable, middle-aged at about 4.6 billion years old. It will shine for roughly another 5 billion years before changing dramatically. This is important because it means Earth orbits an ordinary star, not something rare or exceptional. At a distance of $1 we are positioned within a narrow region where liquid water can exist. Slightly closer and oceans would evaporate. Slightly farther and they would freeze. That delicate balance feels special to us, but on a galactic scale, there may be countless similar arrangements. Now think again about proportion. If the Sun were reduced to a basketball, Earth would be a peppercorn 26 feet away. Jupiter would be a marble more than 100 feet away. Neptune nearly 900 feet away. And the Oort cloud would not fit in your neighborhood. It would extend far beyond your city. The scale stretches so dramatically that even careful models struggle to contain it. The solar system spans trillions of miles. From the inner rocky planets to the outer gas giants, from the scattered asteroids to the distant icy objects, it forms a vast but thin structure. Most of it is empty. If you removed every planet and left only the Sun, the darkness would look almost the same. And still, we remain local. We have not even reached the nearest star. The space between stars is measured not in millions or billions of miles, but in trillions. 1 light-year equals about 5.88 trillion miles. The nearest star system lies more than 4 light-years away. That means if you traveled at the speed of light, you would need over 4 years to reach it. At the speed of our fastest spacecraft, the journey would take tens of thousands of years. Suddenly, the solar system feels smaller. That 2 light-year Oort cloud, which seemed enormous a moment ago, now occupies less than half the distance to the nearest star. Our entire planetary system fits comfortably within the gap separating us from our closest stellar neighbor. Let that sink in slowly. The Sun and all its planets are like a small island floating in a vast ocean. The next island is over 4 light-years away. Between them, almost pure emptiness. Not thick clouds, not dense gas, mostly vacuum. A few stray atoms per cubic centimeter. A darkness so complete it makes the space between planets seem crowded. Even here, in what we call our neighborhood, the dominant feature is not matter. It is void. And within this void, Earth is a small rocky world orbiting 93 million miles from a middle-sized star. Its diameter of 7,926 miles feels substantial when you are standing on its surface. But compared to Jupiter's 86,881-mile width, it shrinks. Compared to the Sun's 864,000-mile span, it nearly vanishes. Compared to the 2 light-year reach of the Oort cloud, it becomes microscopic. Our planet contains oceans, forests, cities, civilizations. But physically, it is just one small sphere among larger ones, circling a star that itself is one of many. Even within our own solar system, Earth does not dominate. The Sun holds 99.86% of the mass. Jupiter outweighs all the other planets combined. Saturn, Uranus, and Neptune add their silent bulk. The asteroid belt barely registers at less than 4% of the Moon's mass. There is a quiet humility in these numbers. No drama, no exaggeration, just scale. From a human viewpoint, Earth feels expansive and central. From the perspective of the solar system, it is one orbit among several. From just beyond the Oort cloud, it disappears entirely. And we have not even left our local region of space. The solar system, spanning trillions of miles, is a tiny structure in the galaxy. Earth, orbiting at $1 around an average G-type star, is a small participant in that structure. Even before we venture to the stars or the Milky Way, the lesson is already clear. Here, in our immediate neighborhood, surrounded by planets capable of swallowing us hundreds or thousands of times, enveloped by a distant cloud stretching nearly 2 light-years outward, we are already small. Now let's drift to the very edge of our Sun's influence and pause there for a moment. Imagine hovering just beyond the outer boundary of the Oort cloud. Behind you stretches interstellar space. Ahead of you is our entire solar system, compressed into something that from this distance would look like a faint, solitary glow. The Sun would be visible, but only as one star among many. The planets would not be individually distinguishable. Earth would not be visible at all. If someone placed a powerful telescope in your hands and asked you to find our world from there, you could not. The distance is too great. Earth is too small. Even Jupiter would be difficult to separate from the Sun's glare. Everything we call home would merge into a single, almost insignificant point. And yet inside that point of light exists every human being, every language, every memory, every moment of love and fear and curiosity. All of it confined to a planet less than 8,000 miles wide. The Sun, so dominant in our sky, so overwhelming in brightness, is itself only one ordinary star. It converts about 600 million tons of hydrogen into helium every second through nuclear fusion. That process releases immense energy, enough to warm our planet from 93 million miles away. Its surface temperature is about 10,000 degrees Fahrenheit. Its core reaches roughly 27 million degrees. The pressure at its center is around 260 billion times the pressure of Earth's atmosphere at sea level. These are staggering numbers, yet they describe something astronomers consider average. Across the galaxy, most stars are actually smaller than the Sun. Red dwarfs, dimmer and cooler, outnumber stars like ours. Many of them will burn for trillions of years, far longer than the Sun's total lifespan. Others are larger, hotter, brighter, but short-lived. The point is this: the Sun is not exceptional. It is one star among hundreds of billions. Now consider again how far light travels. In 1 second, it circles Earth about 7.5 times. In 8 minutes and 20 seconds, it crosses the 93 million miles to reach us from the Sun. In 4 hours, it reaches Neptune. In nearly 2 years, it reaches the distant outer shell of the Oort cloud. These numbers already feel immense. But the moment we step beyond that boundary, the scale expands again in a way that makes even the Oort cloud feel small. The nearest star lies more than 4 light-years away. That is over 25 trillion miles. If you could drive a car at highway speed without stopping, it would take you tens of millions of years to arrive. Our fastest spacecraft, traveling tens of thousands of miles per hour, would require over 70,000 years to cover that distance. The gap between stars is so vast that even light, the fastest thing in existence, needs years to cross it. This means our entire solar system, spanning trillions of miles, is separated from the next system by a gulf of nearly unimaginable emptiness. If you shrank the solar system down to the size of a coin, the nearest star would still be miles away. Between them, darkness, sparse atoms, almost nothing at all. And inside that tiny coin of space, Earth is not the largest object, not the most massive, not the brightest. It is a rocky planet orbiting at $1, held in place by gravity, warmed by an ordinary star. Jupiter outweighs all the other planets combined. Saturn could swallow Earth more than 700 times. Uranus and Neptune each contain dozens of Earth volumes. Even the Sun, which already dwarfs all of them, makes up nearly the entire mass of the system. When you look at the hierarchy, Earth sits near the bottom. Larger than many moons and asteroids, yes, but far smaller than the giants, and infinitesimal compared to the star that anchors everything. There is something steady and calming in this repetition. Each comparison reduces us. Each expansion of scale places Earth in a smaller context. From the surface, it feels vast. Compared to the Moon, it is large but separated by emptiness. Compared to the Sun, it is tiny. Compared to Jupiter, it shrinks further. Compared to the outer boundaries of the solar system, it nearly disappears. Compared to the distance between stars, it vanishes entirely. And yet we are still in our immediate neighborhood. We have not even begun to talk about the galaxy. We are still inside one small stellar system orbiting one ordinary star. If you step back mentally and hold the entire solar system in your imagination, try to see it not as a diagram with neatly drawn circles, but as a vast volume where objects are scattered thinly across trillions of miles. The emptiness is the dominant feature. The planets are rare interruptions in that emptiness. The Sun is the gravitational anchor, and Earth is one small rocky sphere tracing a nearly circular path once every 365 days. Even here, before we leave this local structure, the lesson is clear. We are not central. We are not dominant. We are not large in any cosmic sense. We are small even within the system that formed us. The solar system spans trillions of miles. It reaches nearly 2 light-years outward. It contains planets that could swallow us hundreds or thousands of times over. And at its center burns a star that holds almost all of its mass. Earth is one world among these, orbiting quietly at $1. Even here, in our immediate neighborhood, we are already small. Before we leave this neighborhood behind completely, Let's hold the full picture in one steady frame. The Sun at the center, 864,000 miles wide. Around it, 8 major planets tracing long, silent ellipses through space. The inner rocky worlds clustered close, the gas giants swelling far larger, the ice giants drifting in the cold outskirts. Between them, distances so large that even millions of miles feel small. Beyond Neptune, a sparse belt of frozen remnants. Beyond that, a spherical cloud of icy bodies extending almost 2 light-years outward. Trillions upon trillions of miles in every direction. Now gently imagine compressing all of that into a single image small enough to hold in your mind. The Sun becomes a bright dot. The planets become invisible. Their orbits blur into nothing. The Oort cloud becomes a faint haze surrounding the star. From that distance, the entire solar system is a tiny sphere of influence suspended in darkness. And somewhere inside that sphere, one planet circles at exactly 1 astronomical unit. 1 AU, 93 million miles, 8 minutes and 20 seconds of light travel time. A rocky surface 7,926 miles across. A thin atmosphere hugging its curvature. Oceans covering 71% of its surface. A magnetic field shielding it from solar wind. A moon orbiting 238,855 miles away, separated by about 30 Earth diameters of empty space. Even within the solar system, Earth is defined by relationships that emphasize scale. Compared to the Moon, it is larger, but the distance between them is dominated by void. Compared to Jupiter, it is small enough to fit inside more than 1,000 times. Compared to Saturn, more than 700 times. Compared to Uranus and Neptune, dozens of times. Compared to the Sun, 109 Earths across its face and 1.3 million by volume. And the Sun itself holds 99.86% of all the mass in this entire structure. That percentage matters. It means the solar system is not a collection of equal objects. It is a star with small companions. The planets are accessories to a much larger engine of fusion. The asteroids in the belt together weigh less than 4% of the Moon. The Kuiper belt objects are scattered thinly. The Oort cloud, though enormous in reach, is composed of small icy fragments separated by vast distances. Again and again the same theme appears. Mostly empty. Mostly dark, mostly quiet. The solar system spans trillions of miles, yet if you were to travel through it, you would encounter long stretches where nothing visible passes your window. The cinematic image of crowded space is an illusion. Reality is sparse. The planets are islands. The Sun is a lighthouse. And between them stretches silence. Now step back once more. Place the entire solar system in a mental box and shrink it further. From a few light years away, it is no longer a box. It is a single point. The structure that once felt impossibly large collapses into something almost trivial against the background of stars. Earth disappears first, then Jupiter, then even the Sun becomes one among many. But we are not even there yet. We are still inside our own system, and already Earth has been reduced repeatedly. From enormous to manageable, from central to peripheral, from dominant to minor. On its own surface, Earth feels vast enough to occupy a lifetime. Walking around its equator would take about 3 years at a steady pace. Visiting every square mile, even for a second each, would take years of continuous motion. The scale is meaningful to us. It defines our geography, our history, our sense of place. But place it beside Jupiter and it shrinks. Place it beside the Sun and it becomes tiny. Place it inside the solar system's 2-light-year boundary and it is nearly microscopic. And this is only the beginning. We have not yet crossed the gulf between stars. We have not yet measured the width of the Milky Way. We have not yet compared our sun to hundreds of billions of others. Already, within the first layer of cosmic structure, Earth is small. Not metaphorically small, numerically small, physically small. One rocky planet orbiting one average G-type star at a distance of $1 Australian. A star that itself is ordinary. A planetary system that spans trillions of miles but is separated from its nearest neighbor by even greater emptiness. There is something quietly humbling about recognizing this before we go any farther. Because even here, in what we instinctively call home territory, we are not large. We are not massive. We are not central to the structure. We are participants in a system governed almost entirely by a star that outweighs us by hundreds of thousands of times. And yet, on that small rocky world, awareness has emerged. Oceans move with lunar tides. Continents drift. Life evolves. Consciousness reflects on its own scale. All of that unfolding on a sphere that would vanish from view almost immediately if you stepped back far enough. So as we prepare to move beyond the solar system in the next part of this journey, hold on to this simple realization. We have not even left our immediate neighborhood, and already Earth has become small. Compared to the Moon's distance, compared to Jupiter's volume, compared to the Sun's mass, compared to the nearly 2-light-year reach of the Oort cloud, our world is modest. Even here, in our immediate neighborhood, we are already small. If you're still listening, type 1 in the comments. Now we leave the boundary of our solar system and step into something far more difficult to feel. The nearest star beyond our Sun is Proxima Centauri. It is 4.24 light-years away. A light-year is the distance light travels in 1 year, moving at 186,000 miles per second. In 1 year, light covers about 5.88 trillion miles. So 4.24 light-years is roughly 25 trillion miles. 25 trillion miles. If the distance from Earth to the Sun, 93 million miles, were reduced to a single inch, then the distance to Proxima Centauri would be about 4 miles. Not 4 inches. For miles. That is the scale jump between our star and the next one. Consider Voyager 1, the most distant human-made object ever built. It has been traveling since 1977. For over 47 years, it has been moving outward at about 38,000 miles per hour. That is fast enough to cross the United States in under an hour. Yet even at that speed, Voyager 1 would need about 73,000 years to reach Proxima Centauri. 73,000 years. Human civilization as we know it is only a few thousand years old. Voyager would need dozens of entire recorded histories just to arrive at the nearest star, and it is not even headed in that direction. This is the scale of interstellar space. Between our Sun and Proxima Centauri, there is almost nothing. A few scattered atoms, some stray radiation, vast stretches of cold, silent darkness. Space is not crowded. It is overwhelmingly empty. If you were standing on a hypothetical planet orbiting Proxima Centauri and you looked back toward our solar system, you would see a single star, a faint yellow point in the distance. You would not see Earth. You would not see Jupiter. You would not see Saturn's rings. The entire solar system would collapse into one tiny dot of light. Earth would be far too small, far too dim, far too close to the sun to detect. At that distance, our world disappears completely. And yet, Proxima Centauri is just one star in our stellar neighborhood. It is a red dwarf, much smaller and cooler than our sun. Its diameter is about 14% that of the sun. It burns slowly and could shine for trillions of years, far longer than our sun ever will. Around it orbit at least 2 known planets. Whether they host life is unknown. But even if they did, the gulf between us is almost unimaginably vast. Now let us zoom out further. Every star you can see with your naked eye belongs to our galaxy, the Milky Way. When you look up at the night sky, you are not seeing the universe at large. You are seeing a tiny fraction of one galaxy. The Milky Way is about 100,000 light-years across. From one side to the other, light, moving at the fastest speed possible in nature, takes 100,000 years to cross it. Inside this vast structure are somewhere between 100 billion and 400 billion stars. Each of those stars may host planets. Many likely do. Our sun is just one of them. We are not near the center. We are not in a privileged location. Our sun sits about 26,000 light-years from the galactic center, in a small structure called the Orion Spur, a minor spiral arm between larger arms. We are, in galactic terms, living in the suburbs. The galaxy itself is not static. It rotates, but it does not rotate like a solid wheel. Different parts move at different speeds. Our sun takes about 225 million years to complete one orbit around the galactic center. That is one galactic year. 225 million years for one trip around the Milky Way. Earth is about 4.54 billion years old. That means our planet has completed only about 20 galactic years in its entire existence. 20 times around the galaxy. That is all. The last time the sun was in this exact position in its orbit, dinosaurs had not yet appeared. Entire species rise and vanish in less than a single galactic year. Civilizations flicker in durations so short they do not even register at this scale. And still, we are only inside one galaxy. At the very center of the Milky Way lies something extraordinary. Sagittarius A star. This supermassive black hole contains about 4 million times the mass of our sun. It anchors the galaxy gravitationally. Stars near it orbit at tremendous speeds. Yet even this immense object is tiny compared to the full diameter of the galaxy it inhabits. From a perspective far above the Milky Way, our entire solar system would be invisible. The sun would be just one faint star among hundreds of billions. Earth would not shrink. it would simply cease to be measurable. And between most of those stars, darkness, cold, silent, mostly empty space. If you are still drifting with me through these distances, feeling how the scale keeps stretching and softening everything you thought was large, stay with that sensation. We are only beginning to disappear. Let us keep drifting outward. Imagine rising above the disk of the Milky Way, looking down at it from a distance where its spiral arms become visible all at once. From this vantage point, the galaxy is a vast, rotating structure of stars, gas, and dust, 100,000 light-years wide, softly glowing, slowly turning. Our sun is just one faint point in one minor arm, 26,000 light-years from the center. And Earth is nowhere to be seen, not small, not distant, simply absent. Even if you magnified the entire galaxy until it stretched across your field of vision, the solar system would still collapse into something thinner than a speck of dust. The distances between stars inside the Milky Way are so enormous that even here, within a single galaxy, emptiness dominates. If the sun were the size of a marble, the nearest star would be several miles away. Most of the galaxy is not stars. It is darkness punctuated by light. Now continue pulling back. The Milky Way is not alone in space. It is part of a small collection of galaxies called the Local Group. This group contains about 50 known galaxies bound together by gravity. Some are tiny dwarf galaxies containing only a few million stars. Others are much larger. The largest member of the Local Group is the Andromeda Galaxy, also known as M31. Andromeda is roughly 220,000 light-years across, more than twice the diameter of the Milky Way, contains around 1 trillion stars. That is at least double and possibly several times the number in our own galaxy. Right now, Andromeda is about 2.5 million light-years away from us. Its light left that galaxy before humans existed as a species. When you look at Andromeda in the night sky, a faint smudge barely visible to the naked eye, you are seeing ancient light crossing millions of years of empty space. Between us and Andromeda, there is no crowded field of objects. There are no glowing highways of matter. There is mostly vacuum. A few stray hydrogen atoms per cubic meter. Vast stretches of blackness. The entire Local Group spans about 10 million light-years. 10 million light-years from one edge to the other. Light itself, moving at the fastest speed possible, would require 10 million years to cross this small cosmic neighborhood. And within that enormous span are only about 50 galaxies. That should give you a feeling for how empty even a group of galaxies truly is. From this vantage point, somewhere above the Local Group, the Milky Way is no longer overwhelming. It is one spiral among dozens. And within that spiral, the sun is one ordinary star among hundreds of billions. And Earth does not shrink. It vanishes. The entire solar system would be indistinguishable from a single pixel of light, and even that would blend into the brightness of its parent star. And yet gravity quietly binds this collection together. The Milky Way and Andromeda are slowly moving toward one another. In about 4.5 billion years, the two galaxies will merge. Not in a fiery explosion of stars colliding, but in a slow gravitational dance lasting hundreds of millions of years. Stars will mostly pass by each other without contact because the distances between them are so immense. Even in a galactic collision, emptiness dominates. Now drift even farther out. The local group itself is part of a much larger structure known as the Virgo supercluster. This immense region spans roughly 110 million light-years. Within it are at least 100 galaxy clusters and groups, containing on the order of 100 trillion stars. 100 trillion stars. That number is so large it stops feeling like a number. It becomes a concept without edges. The Virgo supercluster is not a solid object. It is not filled with continuous matter. It is a loose arrangement of clusters and groups connected by gravity, separated by enormous voids. If you could see it from far away, it would look like faint threads of light woven through darkness. Galaxies gather along these threads, leaving huge regions almost completely empty. From this scale, the local group is just a small knot within a larger web. The Milky Way is an unremarkable spiral inside that knot. The Sun is an unremarkable star inside that spiral. Earth is an unremarkable planet inside that solar system. And yet, even calling it unremarkable gives it more attention than it receives at this distance. In truth, it cannot be seen at all. Imagine compressing the Virgo supercluster into a structure the size of a continent. In that model, the Milky Way would be microscopic. The solar system would be smaller than a bacterium. Earth would be far smaller still, beneath any threshold of visibility. Pause for a moment and feel what that means. Every mountain range, every ocean, every city glowing at night, every human story ever told. All of it unfolded on something that disappears entirely once you step beyond even a modest fraction of cosmic scale. And yet most of what fills these immense distances is not violence, not chaos, not constant collision. It is quiet. It is cold. It is empty. The universe, at these scales, is mostly stillness punctuated by islands of light. If you are still drifting with me through this widening darkness, noticing how Earth has not merely become small but has slipped beyond sight entirely, then gently type 2 in the comments. Now let us soften the edges of scale even further. The Virgo supercluster, stretching across roughly 110 million light-years and containing on the order of 100 trillion stars, already feels beyond comprehension. But even that enormous structure is not isolated. It is only one region within a much larger cosmic pattern. If you could drift outward another 100 million light-years, the Virgo supercluster would begin to look like a faint cluster of sparks embedded within something far more intricate, a network. Galaxies do not float randomly through space. They trace enormous filaments, like strands in a cosmic web. Between these strands lie vast voids, regions so empty that a traveler there might wait millions of years before passing near a major galaxy. Most of the universe by volume is not filled with stars or even galaxies. It is filled with darkness and expanding space. Matter collects along thin threads under the slow pull of gravity, leaving behind enormous empty chambers that span hundreds of millions of light-years. Within this web lies a structure known as Laniakea supercluster. Laniakea spans about 520 million light-years. It contains around 100,000 galaxies, including our own. The name means immeasurable heaven, and the scale begins to justify that phrase. 500 million light-years from one side to the other. If light began its journey across Laniakea before complex life appeared on Earth, it would still be traveling today. From this vantage point, the Virgo supercluster becomes a small part of something larger. The local group becomes an invisible cluster inside that. The Milky Way is a single faint swirl. The Sun is a microscopic spark. Earth has no representation at all. There is no analogy left that can comfortably hold it. And still we continue outward. Structures like the Sloan Great Wall stretch across 1.37 billion light-years. The Hercules Corona Borealis Great Wall may span close to 10 billion light-years. 10 billion. That is a distance approaching the radius of the observable universe itself. These are not solid walls. They are vast concentrations of galaxies aligned in extended filaments, like faint brushstrokes across a nearly black canvas. Between them lie voids so large that if you were placed at their center, the nearest significant galaxy clusters might be hundreds of millions of light-years away in every direction. Imagine standing in a darkness so complete that even entire galaxies are distant, faint suggestions. This is not unusual space. This is typical. Roughly 80% of the universe's volume consists of these low-density regions. Now let us step to the edge of what we can observe. The observable universe measures about 93 billion light-years across. That number is larger than the age of the universe might suggest because space itself has been expanding while light travels. Within this sphere are an estimated 2 trillion galaxies. 2 trillion. Each containing millions, billions, or even trillions of stars. The total number of stars is often estimated around 200 billion trillion. That is 200 billion trillion suns scattered across expanding space. If each star were represented by a grain of sand, you would need multiple Olympic-sized swimming pools to hold them all. And Earth? Earth would not be a grain. It would not even be a molecule of sand. It would be something far smaller than anything visible in such a model. Now gently shift from space to time. The universe is about 13.8 billion years old. Earth formed about 4.54 billion years ago. That means our planet has existed for only about 1/3 of cosmic history. Compress Earth's entire 4.54 billion years into a single calendar year. On this scale, simple life appears in March. Complex life does not emerge until November. Dinosaurs arrive around mid-December and vanish the day after Christmas. Humans appear at 11:56 p.m. on December 31st. All of recorded history, every empire, every invention, every war, every symphony, occupies the last 10 seconds before midnight. 10 seconds. Now imagine that single year placed within the full timeline of the universe, which continues for trillions of years into the future. Our entire civilization becomes less than a blink inside an already fleeting moment. In 1990, the spacecraft Voyager 1 turned its camera back toward home from about 3.7 billion miles away and captured an image. In that photograph, Earth appears as a tiny pale dot suspended in a beam of sunlight. Less than a pixel. Not dramatic. Not glowing brightly. Just a faint speck in vastness. That image holds something quietly profound. Every human who has ever lived existed on that speck. Every triumph and failure. Every love story. Every fear. Every question, all confined to something that vanishes entirely once you travel even modestly beyond the solar system. And yet here is the paradox. In a universe 93 billion light-years wide, filled mostly with cold emptiness, this tiny world hosts life. It hosts awareness. It hosts minds capable of measuring the 93 billion light-years and contemplating what it means. The universe is vast beyond imagination, but consciousness, as far as we know, has appeared here. Earth is vanishingly small. That is undeniable. But in a cosmos where most regions are silent and dark, a small, warm biosphere glowing faintly around an ordinary star becomes something extraordinary. Not because of its size, but because of its awareness. If you are still here, still drifting calmly through these scales, feeling both the smallness and the strange significance of it all, gently type 3 in the comments. We have one more widening step to take. Let us take one more slow step outward, and at the same time one step inward. We have drifted across light years, across galaxies, across superclusters and walls of galaxies stretching billions of light years from end to end. We have watched Earth vanish from view again and again, first inside the solar system, then inside the Milky Way, then inside the local group, then inside vast superclusters and the cosmic web. Now we stand at the edge of the observable universe, a sphere about 93 billion light-years across, containing roughly 2 trillion galaxies and on the order of 200 billion trillion stars. From here, there is no further zoom that reveals more structure. Beyond this horizon, light has not yet had time to reach us. But even this observable universe may not be the whole story. Space has been expanding for 13.8 billion years. Galaxies are moving away from one another as space itself stretches. The farther away a galaxy is, the faster it recedes. At sufficiently large distances, that recession happens faster than light can bridge the gap, not because galaxies are breaking the cosmic speed limit, but because space itself is expanding between them. This means there are regions of the universe we will never see, no matter how long we wait. So the 93 billion light-year diameter is not the full size of everything that exists. It is simply the portion we can observe. The full universe could be much larger. It might be finite but vast beyond imagination. It might be infinite. If it is infinite, then the observable universe, enormous as it feels, is just a tiny patch, a small bubble in something without edge. And Earth, already smaller than small, becomes smaller still in significance of scale. Now pause and feel that, not as something frightening, but as something quiet. The universe is not crowded. It is not pressing in. It is not chaotic everywhere at once. It is mostly empty, mostly dark, mostly silent. Galaxies are separated by millions of light years. Stars within galaxies are separated by trillions of miles. Planets are tiny companions orbiting those stars. And on one such planet, circling an ordinary G-type star in a minor spiral arm of an average galaxy, consciousness emerged. Earth is about 8,000 miles in diameter. That is a finite, measurable size. You could walk around it in about 3 years if you walked 8 hours a day at a steady pace. You could cross it in a matter of hours in a jet. You could circle it in about 90 minutes aboard a spacecraft in low orbit. It is small enough to comprehend physically. And yet within that 8,000-mile sphere exists an atmosphere only a few dozen miles thick where all known life survives. A thin film of air clinging to rock, wrapped around a planet that vanishes against cosmic scales. Life began here around 3.8 billion years ago. For billions of years it remained simple, microscopic, unseen. Complex life emerged only in the last fraction of Earth's timeline. Humans appeared in the final seconds of the cosmic calendar year we imagined. And in that final instant we developed telescopes, mathematics, physics. We mapped the Milky Way. We measured the distance to Andromeda. We detected the expansion of space. We traced the large-scale structure of the universe. Think about that contrast. A species that occupies the last seconds of a compressed timeline has managed to measure distances of billions of light years. A mind evolved to navigate forests and savannas can calculate the age of the universe. A brain weighing only a few pounds can conceive of structures like the Virgo supercluster and Laniakea. The physical size of Earth may be negligible, but the reach of awareness that arose here is not. From the perspective of pure scale, Earth approaches zero. If the observable universe were reduced to the size of Earth, the Milky Way would shrink below microscopic scale. The solar system would be smaller than an atom. Earth would be beneath any meaningful measurement. And yet from Earth, we have expanded our understanding outward to the edge of that observable sphere. This is the quiet paradox. Size does not determine significance in a simple way. A neutron star only a dozen miles across can contain more mass than the Sun. A white dwarf the size of Earth can hold half the Sun's mass in compressed form. In similar fashion, a small planet can host something that extends conceptually across billions of light years. Awareness. Now return gently to that image of the pale blue dot, less than a pixel suspended in a beam of sunlight. From 3.7 billion miles away, Earth was almost invisible. From the nearest star, it would be fully invisible. From another galaxy, the entire solar system would disappear. And from the edge of the observable universe, the Milky Way itself would blend into countless others. And yet here you are, listening, imagining, drifting across these scales. The atoms in your body were forged inside ancient stars billions of years ago. Those stars lived and died long before the sun formed. Their remnants became part of a cloud of gas and dust that eventually collapsed into our solar system. The iron in your blood, the calcium in your bones, the oxygen you breathe, all created in stellar furnaces. In that sense, even though Earth is small, you are woven into the larger story of the cosmos. The universe is vast beyond comprehension. Earth is tiny beyond comparison. Most of space is empty darkness. Most of time stretches far beyond human imagination. And still, on this small world, Matter arranged itself into beings capable of asking where they are and how small they might be. That is something the universe does not appear to do everywhere, at least not that we have seen. We have one final reflection to make, a gentle closing to this long drift across scale. Stay with that calm awareness of vastness. Let the numbers soften. Let the distances blur into a quiet sense of perspective. We will bring it home next. Now let us slowly come back, not by shrinking the universe, but by accepting its scale. We have traveled from Earth to the Moon, from the Sun to nearby stars, from the Milky Way to the local group, from superclusters to the observable universe itself. At every step, the same truth revealed itself again and again. Earth is small. Not just small compared to the Sun. Not just small compared to Jupiter. Small compared to a galaxy 100,000 light-years wide. Small compared to a supercluster spanning 110 million light-years. Small compared to a cosmic web stretching billions of light-years across. If the observable universe is 93 billion light-years wide and contains roughly 2 trillion galaxies, then Earth is one planet orbiting one star inside one galaxy among trillions. The odds of randomly selecting our Sun from all stars are almost unimaginably low. The odds of then selecting Earth among the countless planets, moons, asteroids, and comets are even lower. From the standpoint of sheer scale and probability, our world fades into near mathematical insignificance. And yet, that is only one way to measure importance. Scale is not value. Distance is not meaning. The universe does not assign worth based on diameter. On Earth, oceans move in cycles driven by the moon's gravity. Forests grow from sunlight that began its journey 8 minutes earlier at the surface of the sun. Clouds form from water that has circulated for millions of years. Within a thin atmosphere only a few dozen miles thick, life persists in staggering diversity. From microscopic organisms to towering trees, from insects to whales, from coral reefs to rainforests, an intricate web of biology unfolds on a planet that vanishes when viewed from even a modest cosmic distance. Most of the universe is cold. Most of it is nearly empty. Between galaxies are voids spanning hundreds of millions of light-years. Between stars are trillions of miles of darkness. Even inside galaxies, stars are separated by enormous distances. The cosmos is not a crowded place. It is a vast, quiet expanse with rare islands of matter and energy. Earth is one of those islands. If you could hover just beyond the Milky Way and watch it slowly rotate over hundreds of millions of years, you would see spiral arms turning gently, stars drifting in long arcs around the galactic center. You would see no indication that on one tiny rocky world orbiting an ordinary star, there are beings contemplating all of it. From that vantage point, Earth is invisible. But invisibility from afar does not erase what happens here. Consciousness emerged on this small world. Matter that once drifted through interstellar clouds organized into cells. Cells into organisms. Organisms into ecosystems. Eventually, minds capable of reflection arose. Minds capable of asking how far away Proxima Centauri is. Minds capable of calculating that Voyager 1 would need 73,000 years to reach it. minds capable of measuring that the Milky Way is 100,000 light-years across, that the local group spans 10 million light-years, that the Virgo supercluster stretches 110 million light-years. This is the quiet miracle. Not that Earth is large, not that we are central, but that from a place so physically small, understanding has expanded so far. Imagine compressing all the galaxies in the observable universe into faint points of light in a model. Even in that abstraction, Earth would not appear. Yet the thoughts occurring on Earth can stretch across that entire imagined model. Awareness is not bound by physical size in the same way rock and gas are. There is something calming in this perspective. The worries that dominate a single day, the conflicts that feel overwhelming, the small frustrations that occupy attention, all of them unfold on a planet that disappears entirely once you zoom out beyond even our local stellar neighborhood. From the standpoint of the cosmos, they are smaller than small. This does not mean they are meaningless to us. It means they exist within a broader frame that is vast and steady. The universe has existed for 13.8 billion years. It will continue expanding for trillions more. Stars will form and die. Galaxies will merge and drift apart. The Milky Way and Andromeda will eventually collide in a slow gravitational dance. Long after Earth's oceans have evaporated and the Sun has become a white dwarf, the universe will still stretch outward in silence. And yet right now, in this brief window of cosmic time, Earth is alive, warm, active, a small blue world orbiting at just the right distance from its star. A planet where matter has become aware of matter. You are part of that awareness. The atoms in your body were forged in stars that lived and died billions of years ago. The carbon in your cells, the oxygen in your lungs, the calcium in your bones, all created in stellar furnaces before the sun existed. In that sense, even though Earth is tiny, you are connected to the broader universe not as an observer alone, but as a continuation of it. So yes, Earth is vanishingly small compared to 93 billion light-years. It is invisible within the local group, cannot be detected from another galaxy. It is a speck within a speck within a speck. But it is also home. It is the only confirmed world where life exists. The only place we know where the universe has produced beings capable of measuring its own scale. That paradox is worth holding gently. Small beyond comprehension, precious beyond measure. If you are still drifting with me, still feeling both the immensity of space and the quiet intimacy of this small world, type 2 in the comments. And as you let your mind settle, remember this. The universe is vast, mostly dark, mostly empty. But here, on this tiny planet orbiting an ordinary star in an unremarkable galaxy, there is warmth, life, and awareness. Earth may disappear in scale, but for us it is everything. Now we drift outward again, beyond galaxies, beyond clusters, into structures so large they almost feel fictional. Yet they are real, mapped by careful observation and mathematics. Our Milky Way, with its hundreds of billions of stars, is not alone. It is part of something far larger known as Laniakea. The name means immeasurable heaven, and it is fitting. Laniakea spans about 520 million light-years from end to end and contains roughly 100,000 galaxies. 100,000 entire galaxies, each with millions or billions or even trillions of stars, all flowing slowly toward a shared gravitational center. Our galaxy is just one small current in that vast river. If you imagine the Milky Way as a single grain of sand, Laniakea would be a continent made of grains. And yet, even Laniakea is not the limit of structure. When astronomers map galaxies on the largest scales, they see patterns, filaments and walls stretching across unimaginable distances, like a cosmic web woven from light and gravity. One of these immense structures is called the Sloan Great Wall. It stretches approximately 1.37 billion light-years across. A light-year is the distance light travels in 1 year, about 6 trillion miles. So 1.37 billion light-years is not just a number. It is a distance so large that even saying it slowly cannot make it fully real in your mind. If you traveled at the speed of light, the fastest possible speed in the universe, it would still take you 1.37 billion years to cross that wall. And then there is something even larger, the Hercules Corona Borealis Great Wall. Observations suggest it may span up to 10 billion light-years. 10 billion. That is close to the radius of the observable universe itself. When structures approach that scale, our intuitions simply fail. The words become soft symbols for something beyond experience. And still, all of these, Laniakea, the Sloan Great Wall, the Hercules Corona Borealis Great Wall, exist within something even greater. The observable universe measures about 93 billion light-years across. Not because the universe is only 93 billion light-years in size, but because that is the distance light has had time to travel to us since the beginning, accounting for the expansion of space itself. Within this 93 billion light-year sphere, astronomers estimate there are about 2 trillion galaxies. 2 trillion. If each galaxy contained an average of 100 billion stars, the total number of stars would reach roughly 200 billion trillion. That is 200 followed by 21 zeros. Numbers so large they lose personality and become pure abstraction. Here is one way to soften it into something tangible. Imagine that each star in the observable universe were a single grain of sand. Not a pebble, not a rock, just one small grain of sand. To hold all those grains, you would need multiple Olympic-sized swimming pools. Not one pool, several, filled completely with sand. And each grain would represent a sun, perhaps with its own planets, perhaps with its own skies. Now consider this gently. Earth is one planet orbiting one star, just one grain in those swimming pools. At this scale, Earth does not shrink. It dissolves. It becomes smaller than any meaningful comparison. If the observable universe were scaled down to the size of Earth, our entire galaxy would be far smaller than a microscopic particle, and our planet would vanish into conceptual nothingness. And yet, here you are. You are listening, breathing, aware, on a world that is mathematically negligible compared to 93 billion light-years of expanding space. Let that contrast settle softly in your mind. We are tiny beyond comprehension, and we are here. Now let us gently shift from space to time, because scale is not only measured in distance, but in duration. The universe is approximately 13.8 billion years old. That number is almost as difficult to grasp as 93 billion light-years. Billions of years stretch far beyond any human story, beyond civilizations, beyond species. Our planet, Earth, formed about 4.54 billion years ago from a cloud of gas and dust orbiting a young star. If you compare those two numbers, you notice something subtle but profound. Earth has existed for only about 1/3 of cosmic history, roughly 33%. For more than 9 billion years before Earth ever formed, the universe was already expanding, stars were already igniting, galaxies were already colliding and merging in vast gravitational dances. Entire generations of stars lived and died before our planet even existed. The atoms in your body were forged inside ancient stars that exploded long before the sun was born. In a very real sense, you are made of history far older than Earth itself. To make this gentler to imagine, compress Earth's entire 4.54 billion year history into a single calendar year. January 1st becomes the day Earth forms. The early months pass in silence, molten rock cooling, oceans forming under heavy bombardment from asteroids. Life appears relatively quickly in geological terms, perhaps by March in this compressed calendar. But for most of the year, life remains simple. Single-celled organisms dominate. No trees, no animals, no fish, just microscopic life drifting in ancient seas. Multicellular life does not appear until late November. The Cambrian explosion, when complex organisms diversify rapidly, would occur in mid-December. Dinosaurs would arrive around December 13th and disappear by December 26th. And humans? Modern humans would appear at 11:56 p.m. on December 31st. For minutes before midnight, all of recorded human history, from the pyramids to the present day, from ancient languages to modern technology, would fit into the last 10 seconds before midnight. 10 seconds. The rise and fall of empires, the entire span of agriculture, science, art, war, music, philosophy. 10 seconds in a planetary year. Now widen that perspective further. If Earth's existence occupies only about 1/3 of cosmic history, then the universe spent billions of years without this planet. And it will likely continue for trillions of years after Earth is gone. Our sun has about 5 billion years of fuel left before it expands into a red giant, eventually rendering Earth uninhabitable. Compared to the total lifespan of the universe, even Earth's full lifetime is brief. Compared to the future stretching ahead, trillions upon trillions of years of stellar evolution, our current moment is a small flicker, a brief illumination in a vast timeline. And yet, within this thin slice of time, something extraordinary has happened. Matter has organized itself into living systems. Chemistry has become biology. Biology has become awareness. On this small planet orbiting an average star in one ordinary galaxy among 2 trillion, the universe has become conscious of itself. You are a pattern of atoms contemplating the age of the cosmos. That fact alone carries a quiet weight. Now return to space for a moment, but not to immense walls of galaxies. Return instead to a single photograph. In 1990, a spacecraft traveling outward from our solar system turned its camera back toward home. From a distance of about 3.7 billion miles, it captured an image of Earth. At that distance, Earth did not appear as a globe with continents and oceans. It appeared as a tiny speck, less than a pixel in size, suspended in a thin beam of sunlight, a pale blue dot against overwhelming darkness. Every human who ever lived, every ancestor, every child, every thinker, every dreamer, existed on that less than a pixel speck. Every joy and every sorrow, every discovery, every conflict, all of it unfolded on something that, from billions of miles away, is almost invisible. And that image was taken from just the edge of our own solar system. From the nearest star, Earth would vanish entirely in the glare of the sun. From another galaxy, even the sun would disappear into anonymity. From the scale of the cosmic web, our entire galaxy is a faint thread in a structure so vast it defies intuition. Here is the paradox that gently settles in as we consider all of this. Earth is vanishingly small compared to 93 billion light-years. It is smaller than a grain of sand compared to an ocean of galaxies. It is temporally brief compared to 13.8 billion years of cosmic evolution. And yet, as far as we currently know, it is the only confirmed world with life. In a universe that is mostly empty space, mostly cold darkness between distant stars, a small warm biosphere covered in oceans and forests and clouds is extraordinary. Not because it is large, not because it dominates space, but because it contains awareness. Size measures distance. Awareness measures significance. And awareness has arisen here. In a universe that stretches 93 billion light-years across, most of that vastness is empty. The cosmic web may contain walls and filaments of galaxies, but between those structures lie enormous voids spanning hundreds of millions of light-years. Inside those voids, galaxies are sparse, scattered thinly through darkness. If you could stand in the center of one of those regions and look outward, the nearest major cluster of galaxies might be a billion light-years away. The night would not sparkle with dense starlight. It would feel quiet, spacious, almost still. The universe, despite its immense inventory of stars, is overwhelmingly empty. Matter gathers in islands. The rest is silence. And within one of those islands, inside a single spiral galaxy, in the outer regions of a minor arm, orbits a small rocky world with oceans, atmosphere, and life. Earth is tiny in distance and brief in time, yet it carries something the surrounding void does not. Warmth, chemistry, breath. The thin layer of atmosphere surrounding our planet is only about 60 miles thick if you measure where most of the air resides. 60 miles. Compared to Earth's diameter of nearly 8,000 miles, that protective blanket is thinner than the skin of an apple. Compared to interplanetary distances, it is nothing. And yet within that delicate envelope, clouds form, winds circulate, rain falls, and life persists. The biosphere, the region where life exists, extends only a few miles into the oceans and a few miles into the sky. On cosmic scales, it is a fragile film clinging to a sphere drifting through space. If you could hold the entire observable universe in your imagination at once, 2 trillion galaxies, roughly 200 billion trillion stars, Earth would not stand out because of its size. It would stand out because something here reflects on that scale. On this world, the universe has produced beings capable of measuring 13.8 billion years and mapping 520 million light-year superclusters. That ability is rare in a cosmos that is otherwise indifferent. The laws of physics operate everywhere, but awareness of those laws seems, at least for now, confined to a thin blue world. Think again about the compressed calendar of Earth's history. Humans arrive at 11:56 p.m. on December 31st. Civilization fills the final seconds. In that tiny slice of time, we have learned to calculate the expansion of space, to detect galaxies billions of light years away, to trace the afterglow of the early universe. All of this happened within the last 10 seconds of a planetary year. It is astonishing not because we are large, but because we are small and brief, yet capable of understanding immensity. The pale blue dot image captures this perfectly. From 3.7 billion miles away, Earth is almost indistinguishable from noise in the camera. A faint point of light suspended in darkness. If you did not know what you were looking at, you might miss it entirely. And yet, on that, forests grow, oceans shimmer, languages evolve, children learn to speak, and minds ask questions about existence. That contrast between scale and experience is the quiet heart of the paradox. We often associate importance with size. Mountains seem more significant than pebbles. Oceans seem more powerful than raindrops. But the universe gently challenges that intuition. Jupiter is 1,321 times Earth's volume, yet as far as we know, it is lifeless gas and storm. The Sun could contain 1.3 million Earths by volume, yet it does not think or feel. A galaxy may contain hundreds of billions of stars, yet it does not contemplate itself. Awareness has emerged not in the largest structures, but in a small, rocky environment with liquid water and stable temperatures. In a universe mostly empty and cold, warmth is rare. In a universe mostly dark, a world illuminated by a steady star is uncommon. In a universe governed by physical law, the emergence of consciousness capable of reflecting on those laws is extraordinary. Not because it changes the expansion of space or alters the gravitational pull of galaxies, but because it introduces meaning into matter. The cosmos does not shrink because we are here, but our presence gives one tiny region of it an interior perspective. When you step outside at night and look at the stars, you are looking at distances so vast that light itself required years, centuries, or millennia to reach you. Yet the act of looking collapses that immensity into a moment of perception. A photon travels for millions of years, then ends its journey in your eye. In that instant, cosmic history meets awareness. That meeting happens nowhere else that we can confirm. Earth's smallness does not diminish it. It refines it. It reveals how delicate and improbable our circumstances are. The same gravity that shapes galaxy clusters also keeps your feet on the ground. The same nuclear processes that power distant stars forged the carbon in your cells. The same expansion that stretches intergalactic space also defines the cosmic horizon we observe. We are not separate from the universe. We are a local expression of it, brief but luminous. And so the paradox remains gentle but profound. Earth is vanishingly small compared to 93 billion light-years. It occupies a negligible fraction of cosmic volume. It has existed for only a third of cosmic history. Yet here, on this small sphere, the universe has become capable of self-reflection. Not because of size, but because of awareness. When you hold all of this together, the 520 million light-years of Laniakea, the 1.37 billion light-years of the Sloan Great Wall, the possible 10 billion light-years of the Hercules Corona Borealis structure, and the full 93 billion light-year diameter of the observable universe, something subtle begins to shift inside you. The numbers stop competing with one another. They stop trying to impress. Instead, they dissolve into a single quiet realization. We live inside something immeasurably vast. 2 trillion galaxies, roughly 200 billion trillion stars, oceans of darkness between islands of light, and on one unremarkable spiral arm in one ordinary galaxy, a thin blue atmosphere wraps around a small rocky world. It is easy when confronted with this scale to feel diminished, to feel as though smallness equals insignificance. But smallness in space does not mean smallness in value. The universe measures size in light years. Life measures meaning in experience. Those are different dimensions. Earth is tiny in physical scale, yet it contains every love story ever told, every song ever sung, every memory ever formed. Every human who ever lived, from the first hunter-gatherers to the people alive right now, has walked, breathed, and dreamed on that less than a pixel speck captured from 3.7 billion miles away. Imagine again that image. The spacecraft had already traveled beyond the outer planets. Turn back one last time. Against a beam of scattered sunlight, a faint dot appeared. That dot was not labeled in the original data. It was almost lost in glare. But when identified, it revealed something extraordinary. All of human history suspended in a single mote of light. All wars fought on it. All discoveries made there. All quiet evenings. All whispered conversations. All acts of kindness and all mistakes. Entire civilizations rising and falling on something that, from a modest cosmic distance, nearly disappears. And yet, that disappearance is only visual. Physically small does not mean existentially trivial. In fact, the very fragility of Earth is what makes it remarkable. The biosphere is thin. The climate balance is delicate. The span of human history is brief. If you compress Earth's existence into a single year and place humanity in the last 4 minutes, then every decision we make occupies the final seconds before midnight. We are recent arrivals on an ancient stage, but we are also the first, as far as we know, to understand the stage itself. The universe is 13.8 billion years old. Earth formed 4.54 billion years ago. For billions of years, stars fused hydrogen into helium without witness. Galaxies collided silently. Black holes merged in darkness. Then, on this planet, chemistry organized into cells. cells organized into ecosystems. Eventually, nervous systems evolved capable of modeling reality. Now the cosmos can be described, measured, and contemplated from within. Not because Earth is large, but because it is alive. Consider what dominates the universe by volume. Not planets, not stars, mostly vacuum, mostly emptiness. The average density of matter in the universe is astonishingly low, far emptier than any laboratory vacuum on Earth. Galaxies cluster along filaments, but between them stretch regions nearly devoid of structure. Cold radiation drifts through space. Darkness fills the majority of cosmic real estate. Against that background, a warm ocean world with stable liquid water and a breathable atmosphere is rare by comparison. A place where molecules assemble into self-replicating systems is rarer still. A place where those systems become conscious is rarer again. The paradox softens when you sit with it long enough. Yes, Earth is vanishingly small compared to 93 billion light-years. Yes, our solar system is just one among countless systems scattered across 2 trillion galaxies. Yes, our species appeared in the final seconds of a compressed planetary year. But awareness changes the equation. A single conscious moment contains more subjective richness than a billion years of unobserved stellar fusion. A quiet human thought about the stars is, in its own way, as extraordinary as the stars themselves. When you lie beneath the night sky, you are not separate from what you see. The atoms in your body were forged in ancient supernovae. The oxygen you breathe was once inside massive stars. The calcium in your bones formed in stellar cores. You are not merely standing on the pale blue dot. You are a temporary arrangement of cosmic material capable of reflecting on its origin. That ability does not enlarge Earth physically, but it transforms how we interpret its scale. And so we arrive at a gentle conclusion. Earth is tiny beyond comprehension. Its diameter of nearly 8,000 miles means nothing against 93 billion light-years. Its 4.54 billion years are brief against cosmic eternity. This biosphere is thin. The civilizations are young. Yet it is home. Home not in a sentimental sense alone, but in the literal sense that every known instance of life, every confirmed spark of consciousness, exists here. In a universe mostly empty and cold, a small warm biosphere is extraordinary. Not because it occupies much space, but because it hosts awareness. If you are still here, still drifting through these scales with me, type 3 in the comments. Let it be a quiet acknowledgement that you have traveled from superclusters to seconds, from cosmic walls to calendar years, and returned safely to a small blue world. And as you settle into rest tonight, remember this: though Earth is tiny beyond comprehension, it is the place where the universe has learned to look back at itself. It is the place where matter became memory, where stardust became story. It is small, yes, but it is home, and for now that is enough. As we come to the quiet end of this journey, let everything settle into a single, steady perspective. We began by stretching outward to 520 million light-years, to superclusters flowing like rivers of galaxies. We expanded to walls more than 1 billion light-years long. We imagined a structure possibly 10 billion light-years across. And finally, we held the observable universe itself in view, 93 billion light-years from edge to edge, containing around 2 trillion galaxies and roughly 200 billion trillion stars. Against that immensity, Earth is not simply small. It is vanishingly small. If every star were a grain of sand, multiple Olympic swimming pools would be required to hold them. Our sun would be one grain among those countless others. Earth would be smaller still, a speck orbiting one ordinary grain in an ocean of cosmic sand. Then we shifted to time. 13.8 billion years of cosmic history. Earth forming 4.54 billion years ago, only about a third of that timeline. We compressed those billions of years into a calendar year and found ourselves arriving just before midnight on December 31st. Human history fitting into the final 10 seconds. 10 seconds in a planetary year. That perspective does not erase our story. It refines it. It reveals how brief and luminous it is. Every human achievement, every act of kindness, every mistake, every breakthrough, all unfolding in those final seconds. And yet, those seconds matter, because within them awareness emerged. On this small world, chemistry became biology, biology became consciousness, and consciousness began to ask questions about its own origin. The pale blue dot image captured this contrast perfectly. From 3.7 billion miles away, Earth is almost invisible, a faint pixel suspended in darkness. But on that pixel, forests breathe, oceans circulate, minds reflect. Every person who has ever lived existed on that dot. Every civilization, every dream, every quiet moment of reflection, all contained within something that, from modest cosmic distance, nearly disappears. It is tempting to think that size determines importance, that bigger must mean more significant. But the universe does not operate on human intuitions. Giant stars burn and die without memory. Massive galaxies collide without awareness. Superclusters stretch across hundreds of millions of light-years in silent gravitational choreography. None of them, as far as we know, pause to wonder. Awareness, at least in this corner of the cosmos, exists here, on a small rocky planet orbiting an average star. The universe is mostly empty. Vast voids dominate its volume. Intergalactic space is so sparse that a cubic meter may contain only a few atoms. Darkness outweighs light. Cold outweighs warmth. Yet here on Earth, liquid water flows. Temperatures remain within a narrow range. Atmosphere shields the surface. Life persists. This thin biosphere, stretching only a few miles above and below the surface, is fragile compared to cosmic distances. But it is precisely that fragility that makes it extraordinary. A small, warm layer of living complexity suspended in an immense, indifferent expanse. Earth does not need to be large to be meaningful. It only needs to host experience. And it does. Every sensation you have ever felt, every thought you have ever formed, has unfolded within the narrow boundaries of this planet. The same gravitational forces that shape galaxies also hold you gently to its surface. The same physical laws that govern distant superclusters operate in the neurons of your brain. You are not separate from the cosmos. You are a local expression of it, a brief, conscious configuration of ancient atoms. When you consider 93 billion light-years, it can feel overwhelming. But scale does not diminish intimacy. You do not experience 93 billion light-years. You experience breath, heartbeat, memory, curiosity. The universe may be enormous, but your experience of it is immediate and present. That is where meaning resides, not in kilometers or light years, but in awareness. So here is the paradox, resting quietly at the center of everything we have explored. Earth is unimaginably small compared to the observable universe. It is temporally brief compared to cosmic time. It occupies an almost negligible fraction of space. And yet, it is the only confirmed world where life exists. The only place we know where the universe has become conscious. Not because of size, but because of awareness. As you drift towards sleep tonight, let that thought soften your perspective. The worries of a single day unfold on a planet that itself is a speck in a vast cosmic ocean. That does not make your life meaningless, places it in context. You are part of something vast and beautiful, even if your physical footprint is small. You live on a world that is tiny beyond comprehension, yet rich with life, memory, and wonder. If you have traveled all the way here, from superclusters to seconds, from billions of light years to the thin atmosphere surrounding this planet, you have completed the full arc of scale. From the largest known structures to the smallest moments of awareness. Earth is small. The universe is immense. But this small world is home. And in a cosmos mostly empty and cold, home is extraordinary. Rest gently with that. The universe is vast. Earth is tiny, but it is ours. And that is enough.